Hey guys, the very first video of Packet Tracer from the ground up playlist is starting right now. Here we go. Hey guys, so this is the very first video for the very first lab of the Packet Tracer from the ground up playlist. What we're going to be doing today is we're going to be reviewing the topology I built for this several labs of this series for this playlist. This is going to have the overall topology. We're going to see what the configuration is kind of going to look like as far as the physical configuration and talk about what we're going to incorporate within this lab or these series of labs. Let's take a look at it. Hey guys, so here's the Packet Tracer application that we're going to be utilizing for this lab. And we went to the About section so you can look at the version of the Packet Tracer that I'm using. Currently, I'm using version 7.3.0.0838. It's the current installation for Packet Tracer as of the recording of this date. Now let's get looking at the topology. Okay guys, so I took a screenshot of this topology and kind of I had to zoom out to take a screenshot, and I zoomed the picture in overall so we can get a decent look at it. So the yellow that you see, that's all going to be EIGRP, and it's going to be all one autonomous system number. The green is going to be BGP, and we'll configure that afterwards. So we're going to incorporate several different things here, and let's take a look at what we're going to incorporate. So the HQ network is this right here. This is the HQ network, okay? And that's the one we're going to focus on configuring first. That's where most of the configurations for the LANs and the HSRP and STP is going to reside in. The second portion of that is going to be down here at the branch A. So that's going to be right here, okay? That's also in the EIGRP network. And that's the second biggest LAN that we're going to be configuring, okay? Then the third branch is going to be this one right here, okay? That is branch B. It's basically like a small offsite. They're going to be utilizing router on a stick for the inter-VLAN routing. They don't even have a server, so all the DHCP for the PCs is going to be controlled on the router. It gives us a different configuration from the inter-VLAN routing on the layer 3 switches as we see in the other two branches. Okay, so that's number one. Well, let's talk about the BGP portion right here real quick. So if you look here, the HQ network, which is this right here, that's the HQ. And right here is branch A. Okay, so what we're going to end up doing is they have two routers that are connected to the EIGRP network, and we're going to assume that those are DMVPN tunnels in real life, right? They would be going over MPLS or ISP DIA circuits. For the sakes of these labs, we're just going to configure the the ISP routers inside that EIGRP as EIGRP, so they show up as regular routes. With the green, where the BGP is, we're going to set up basically a tertiary connection. So if both primary and secondary router goes down, the routers will use that will create a GRE tunnel through BGP to reach the other branches. Okay, and they will actually be a GRE tunnel here virtually, so in case this goes down or whatever else goes down, they can reach each other. So HQ is using a non-collapse core design. What I mean by that is right here is the WAN routers, okay? And this one here. That's an ISP router. We're going to put internet to the edge through the BGP, and we're going to simulate the internet right there, okay? So CE1, CE2 is basically MPLS, DMVPN, whatever you want to use. It's going to be the connections, the primary and secondary connections into the business network. HQ CE3 is going to be the internet connection, okay? And we're going to simulate the internet with that iNet server right there. So anything that's not business related, if it's a public IP address, it's going to be routed through that. But that's also going to serve as a DMVPN, or not, sorry. It's not going to be serving as a DMVPN because Packet Tracer does not support DMVPN. we're going to create a GRE tunnel, which is the bare bones of DMVPN, to connect to from HQ to branch A. Okay, so if those two routers go down, boom, we can pop over and use that GRE tunnel for business traffic as well as internet. Okay, that's there. But anyways, so as we were going, the primary WAN routers. Right here is what we're going to use as an external switch. So we'll get to that in a second, but all three of the WAN connections connects into that external switch. Right here, this is a traditional 3-layer design. This is your core routers. This is your distribution switches. And I misspoke. So this right here is actually your core switches. They're layer 3 switches. They're going to be doing the inter-VLAN routing. This right here is your distribution switches to distribute the connections from the core layer down to the access layer, which is right there. Okay. So that's the 3-layer tier design from Cisco. Over in branch A, you have your WAN routers here, you have your internet router there. They all connect to that external switch, and again, we'll talk about that in a few minutes. Okay. And then they're using a collapsed core design, meaning your core switches, which is where your layer 3 switches are, and they're going to be doing the inter-VLAN routing. They're also serving as the distribution switches. So it's taking that distribution layer and that core layer and combining them into one single layer. So if you would divide that in half, basically this would be layer 3, this would be layer 2, and it'd have a logical separation, right? More or less. Okay. And of course, and then branch B is router on a stick, where all the inter-VLAN routing is going to be handled at the core or at the router itself. So let's talk about the external switch and why it's playing a part in these topologies. And we'll start with HQ, right? Because that's where you see the most connections. So typically with a core, you would have VSS cores. So you'd have your one core chassis and your second core chassis. So this would be core chassis 1, core chassis 2, and they would be linked by VSS and be under one management IP. Packet tracer does not support VSS. So what we're doing is we're creating two management IPs. We're interlinking the two via port channels. And that's how we're going to run that here. Same thing with the distribution switches. They would be stack-wise VSS type technology, making it a single management point, but making them two different data planes themselves. And those connections would be load balanced between switch A or blade A and switch B or blade B underneath one single management point. Since that's not the case here, again, because Packet Tracer does not support Stackwise or VSS, we are load balancing the connections from the access switches to distribution 1 and distribution 2, and then we're doing an X pattern with a box around to provide full mesh redundancy between the distribution layer and the core layer. And that's why we have that external switch, is to take all of those connections into one device and then create a load balance connection between the two. Now, in reality, what you would end up doing is the customer end router would be connecting into port 1, customer end router 2 would be connected into port 2, and since those would be under a single management plane, a single management IP, they would show as connected to the same device, even though they're two physically separate hardware. That way, if this one dies, this one here would kick up and it'd have that connection to customer end 2. So we're just kind of simulating that aspect of load balancing. So let's talk about what we're going to configure. So as you can see here, inside the distribution and core layers, there's going to be multiple trunk ports. And those trunk ports, we're going to configure port channels. So LACP, PAgP, and just Ether channel on. We're going to walk through all three of those configurations. and the pros, the cons, figuring out what's the best ones we can use for this topology and kind of how we're going to go about everything. And then here, between the distribution and the access layers, we're not going to use port channels because the port channels are not going to work between the two different distributions. I might take one or two switches and double up the connections to configure a port channel. Okay. So then we can look at how we do the VLAN allowed on the trunks on the port channels and see, do you do it on the physical interfaces themselves or do you do it on the logical port channel, and seeing how that's going to mess up the topology or not going to mess up the topology. So that's where we're going to go in with that. The other aspects we're going to do is STP. So if you look right here, right, that switch, it's a layer 3 switch, but it's going to be layer 2 only for this lab. That is it's the root bridge, right, in STP right now. I did no configurations to this topology, so by sheer luck, that is the root bridge. We don't want one of our access switches being the root bridge. So we're going to walk through how we can make the core 1 the root bridge primary. We're going to walk through how we can make that the root bridge secondary. And then we're going to walk through how we can make sure all of these switches can never take the root bridge. And that's going to be controlled by these two distribution switches right here. So we'll walk through that configuration as well. The other aspect we're going to do, we're going to look at all the dynamic trunking protocols. We're going to look at .1Q. We're going to see if we can look at those packets. The other thing we're going to look at is VTP. So this is going to be a VTP server. This is going to be a VTP server. This is going to be VTP transparent. And then all of these right here, they're going to be VTP clients. So they cannot modify the VTP database. So we're going to walk through that configuration. The other thing we're going to do is we're going to configure DHCP both on routers and on servers. So if you look at HQ, it has a server right there. And then on branch A, it has a server right there. Those two networks are going to have DHCP hosted on the server. So we're going to configure the VLANs to operate on that server. The other thing I'm going to do is, and you don't see it in this topology, but I will modify the topology before we post it. Speaking of which, if you look down in the description, you're going to see a link to this topology on a Google Drive. Navigate to it, download it, and this topology will be made you'll have access to this topology so you can follow along through these labs. So every lab that we do, you're going to have the topology when we start the lab, and you're going to have the topology after we start the lab. That way you can compare the two of how you configured it versus how I configured it and see if you see any differences. So anyways, back to what I was saying is right now that server is only connected to port 1. We're going to actually take port 2 and connect it to that same server. So that way it has redundant configuration connections. And same thing over here. We're gonna add those two connections in the topology before I post it online. And before we start the actual lab that we're gonna do. The other thing we're gonna look at is TACAX access. So the HQ right there, that server is going to configure TACAX access, and all the switches, all of the routers, as long as they're within the EIGRP routing domain, routing autonomous system, they're going to be configured for TACAX access, and we're going to set up TACAX access to take precedence over a local account, and then if TACAX access is not available, it'll default to local account. So we'll walk through that configuration as well. The other thing I want to take a look at, and we want to try to do, is if you look right here in the VLAN table, is you'll see where it has rspan VLAN. What I want to look at is the ability, or packet tracer's ability, because I know we can do it in real life. I want to look at packet tracer's ability to do rspan in the network and be able to monitor specific switch ports on that VLAN, showing how to create that monitoring system monitoring VLAN, the RSpan VLAN, and how to utilize that on Packet Tracer. Try to simulate that as much as possible into the real world as you would do every day. So let's talk about the internet, how we're going to utilize that BGP routing and that iNet server up here in the green access area. So all business traffic, so all private VLANs are going to be routed through the EIGRP. And no private VLANs are going to be routed through BGP unless it's through the GRE tunnel. If everything is working correctly, assuming that we're going to configure it for EIGRP equal cost load balancing, traffic is going to come up through here and get load balanced between here if it's EIGRP routable traffic, meaning private VLANs. And it's going to be routing to either that network or that network. Now, while that is still running, if something goes to, say, google.com, not google.com, but we'll create some non-private addresses via web hosts, maybe on this server right here, to where we can trace and it'll come through this router, this connection, and come out that way. That way, in the real world, what you would do is you'd have that connection to offset your internet. That way your business critical traffic is not affected by big downloads from Google or whatever other internet source you have. But then that router is also going to create the GRE tunnel between the branches here. The other thing we're going to look at is we're going to do port security, and mess with port security. We're going to look at static MAC addresses on the ports. We're going to look at max count MAC addresses on the ports. So if you look here in the HQ side, each switch has a connection to the PC. What we're going to end up doing is breaking one of these connections. It might not be that one, but we're going to assume it's that one for right now, and putting a little hub in here, and then we'll connect 2 or 3 PCs into there and see if we can configure the port security to not allow that, so that way it doesn't break spanning tree, especially if we take, say, a hub here, we connect 2 or 3 PCs to it, but then we also connect it to a switch, or maybe connect it to the switch down here, right? We want to make sure that we configure port security in a way that it's going to realize that it's going to shut that port down so it doesn't create an issue within our network. The other thing we're going to look at is port fast. So all of these edge connections, if you don't configure port fast, the edge connections, every time they go up or they go down, it creates a topology change BPDU. And that topology change BPDU does different things, whether you're running PVST or STP. But basically, it tells the spanning tree instance to perform some sort of action to age out MAC addresses or age out connections. And then they got to go through that whole process. So PVST, if it's got to go through that whole process, that's another 30-second wait if it gets dropped from the ARP table. So we're going to configure those as port fast, which makes them edge. So every time they go down or go up, it doesn't reconfigure or do a topology change through the entire network, the layer 2 network, which adds for network integrity. So as you see, we have a lot of things planned for this network. We have a lot of things planned for this lab in topology, and we're going to walk through it, right? So we're going to start at the HQ network, and we're going to build out simple things, VTP, trunks, and then we're going to work our way into routing. And once we work our way into routing, we're going to work our way through the ISP network and then into branch A and branch B, and then we're going to configure the BGP iNet side. And we're going to really go through what you really need to do mostly in a real world environment to configure a network like this as close as possible, as accurately as possible in an everyday situation. So we're not going to touch onto every aspect or every possibility, but we're going to cover a lot of material just with this one topology. And then again, this is EIGRP only. We're going to then wipe it. We're going to create a new topology in the next lab series, which will be topology 2. And that topology will contain OSPF. It'll contain stub areas and total stub areas. So We have a lot of stuff planned for this topology. We have a lot of stuff planned in the next several videos, and we're gonna walk all this configuration out. We're gonna go through every piece of it. We're gonna troubleshoot it and show you different ways how it's running this way or it's running that way. It's gonna break and how you fix it. So I hope you guys really enjoy this playlist, this lab, this topology, these build videos, and stay tuned, right? So have a good day, and can't wait to see you at the next video.